Alright, in this problem we're going to find the exponential function where y equals ce to the kt, and it passes through the two given points. So what I'm going to need to do first of all is just look at how I can use these points to be able to figure out what c is. So what I'm going to do is start with the general form they give me, and I'm going to plug in 0, 4. So I'm going to put 4 in for y and 0 in for t. That allows me to go ahead and say that c is equal to 4. So I now have the equation y equals 4 e to the kt. Now if I plug in 1/2 for my y and 5 for my t, I'll be able to figure out what k is. First thing I have to do is divide by 4 on both sides. That gives me 1/8 equals e to the 5k. Now I can get k by itself by ln'ing both sides. That makes those fall away when you bring the power out front. So we get 5k is equal to the ln of 1/8 divided by, I'm jumping ahead here a little bit. Let me go ahead and write out one more step. So I end up with k is equal to ln of 1/8 divided by 5. This means that k, when you put it in your calculator, is approximately negative 0.4159. That allows me to go ahead and write the specific equation y equals 4 e to the negative 0.4159 t. The next thing we're going to go ahead and look at is completing the table. The way we're going to complete table is we're going to be using half-lives. The formula we're going to continue to use is this y equals c e to the kt. I'm going to be able to determine a half-life due to the information that's here. So if you have an initial quantity of 20, and you know that you want half of it, that's what half-life does, cut it in half, then we can go ahead and plug in 20 as my initial amount, and I want to end up with 10. The half-life I know in times is 1,599 years. And what that's going to let me do is divide by 20 on both sides, which gives me 1/2. Then what I can do is ln both sides. So I now have the ln of 1/2 is equal to the ln of e 1599t. And then what I can do is divide. I'm squeezing that in here. Divide by 1599. Now what I'm going to be able to do is figure that out after 1,000 years, how much is left. So I now know, and I have this written wrong, this is a k. Sorry about that. I flip-flopped my order, and then I didn't flip-flop my variable. So now I can figure out after 1,000 years how much is left. So my initial amount is 20. E to the k. K is ln of 1/2 divided by 1599. And then we'll multiply that by 1,000. That is approximately, when you plug that in your calculator, 12.96 grams. You do the same thing to figure out the amount after 10,000 years. This is all calculator based. And I'm not showing you the calculator. You guys should practice putting this in. It's e to this times now 10,000. This gives you an approximation of about 0.26 grams. Alright, on this problem you can see I'm trying to figure out different amounts. Here I want my initial quantity, and I want them out after 10,000 years. I'm going to use that same formula, y equals CE to KT. Now, I can go ahead and pull things from my last problem. My half-life, my K value, which I still didn't fix here, my K value is ln of 1/2 divided by 1599. My C value is what I'm trying to find. All I know is that after 1,000 years, that was my time, I have 1.5 grams. Now I'm going to be able to go ahead and find what C is by dividing both sides by this E. And when I do that, C is approximately 2.319. So my initial quantity is 2.319 grams. Now I can go ahead and figure out the amount left after 10,000 years. I have a tickle in my throat, so it's causing me to go in and out a little bit. I apologize for that. Everything else remains the same. The only thing that changes is that I'm now multiplying by 10,000 for my T. Again, this is all calculator based. You need to type that in your calculator. You'll end up with the answer of approximately 0.03 grams. On my next problem, I'm talking about an investment. So these instructions aren't right. This would be for an investment. This time we write it a little bit different. It's actually the same equation. It just looks a little bit different. We call it A equals PE to the RT. Instead of K and C, we now have our principal rate and our rate, our principal amount and our rate, our initial investment. So in the first problem, I have my initial investment being $18,000. My rate is 0.055, and T is unknown. I want to know the time it takes to double it. So use my initial investment and double it. So when I divide by 18,000 on both sides, I get 2. Now I'll unload both sides. And that will give me that T is equal to the ln2 over 0.055. So T, the time it takes to double, is approximately 12.6 years. Now I can go ahead and use that to be able to figure out the amount left after 10 years. So when I put all that in my calculator using my new time, I actually don't have to use my new time. I'm just using 10. I will end up with an approximate answer of $31,198.55. Now we found out that it takes 12 and a half years, a little over 12 and a half years to double. Notice how it's not quite there after 10 years. So my answer does make sense. Alright, in this next one I've got another initial investment. So those instructions are wrong. This time our initial investment is $12,500. I am trying to figure out the annual rate. So I'm trying to figure out R. I know the time it takes to double is 5 years. So that really means for it to get to 25,000, then I have this new equation. Because 25,000 is double 12,500. So when I divide by 12,500 off both sides, I get 2. Then I'll end both sides. And I get R is equal to the ln of 2 divided by 5. So that makes R approximately 0.1386 or 13.86%. I can now figure out the amount after 10 years because I know my annual rate, and I'll put in 10 for my years. My initial investment stayed the same. So the amount after 10 years is approximately $50,000. We're going to look at one more example. This one's asking me to compound it monthly. We haven't worked with that formula in a while, but the formula is A equals P times 1 plus R over N to the NT power. It wants me to be able to figure out P that's invested at this rate R for T years. So it wants me to find the principal. So they want us to be able to have $1 million at retirement. So that's my ending amount. I don't know P. I know my rate is 0.06. The number of times we're compounding it is 12. And we're doing that for 40 years. So really we're just dividing 1 million divided by 1 plus 0.06 over 12 to the 12 times 40. I'm not going to tell you what that is as a decimal right now. I would just put it strictly all in my calculator at one time. If you're having issues with that, you'll need to break it up. But our initial investment would have to be $91,262.08. So that means for us to end up with $1 million at retirement, we'd have to invest initially over $91,000 at a 6% rate that's compounded monthly.